Welcome to Bravel Institute. Today we are discussing about stationarity. What is stationarity? What types of stationarity is there? So we are discussing about two types of stationarity. One is strictly stationary and other is weakly stationary. Two types of stationarity, strictly stationary and weakly stationary. It is a very simple concept. We will explain through one deterministic process. I will say one example. It is a deterministic process, but we can understand the concept of stationarity. Once upon a time, in our village, there is one sweet shop. He is selling 100 packets of halwa. He is selling halwa, only one product. It's one of the special types of sweets is halwa. So day one, he sold 100 halwa. He will open the shop at 5 o'clock and he will sell the maximum 100 packets only. Every day he sold 100 packets. Day 10 also he sold 100 packets. Day 30 also 100 packets. There is a huge demand for this halwa, but he is selling only 100 packets. This special types of seed. You see, if you draw the one graph, you will understand. Day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll just take 10 days. It's a 100. So it is a time is going there, and it is a sales is constant 100. If you compare with from day 1 to day 30, it is doing the same last 5 years. So you see the sales graph is horizontal, it's a straight line. And now we are comparing the statistical properties of different times. Now for example, I am taking from 1 to 4. I am taking from 1 to 4. What is my statistical properties? It's like E of X, variance of X, covariance. So my statistical property I am comparing with the first 1 to 4 and 6 to 10. In this period, what is my expectation of X and variance of X and covariance? My statistical property, this is maybe 100, maybe 0. My statistical properties are remain same from this period 1 to 4 and 6 to 10. Here also same, here also same, this also same. So all in this period, all statistical properties are same. Now we changing the time. Now we change the time from, I just taking from 4 to 6 and 8 to 10. Now I'm changing the time. I'm taking from 4 to 6 and 8 to 10. You just check the expectation of X and variance of X and covariance of in this time interval. This is also same. So if you take another one more time interval, 2 to 4 and 6 to 8, if you take like that 2 to 4 and 6 to 8 in this time interval. So wherever you take the different time interval, the statistical properties are remain same. So we can say it is a time independent. Time is independent. We can say it is time independent because wherever in this point, in this straight line, in this process, wherever we take, the statistical properties are remain same. So it is a time independent. If you compare with one stochastic process, this is a one deterministic process. Now we comparing with the one stochastic process. You see the stochastic process will be like that. Stochastic process we can't say is like a straight line. So stochastic process will be like that. If you take the statistical properties of this is maybe 1 to 100, this time interval will be 1 to 100 and 200, 300, 400. Time interval is going like that. Set time. If you compare with from first 100 time, from to here to here, and 200 to 300, if you compare from this time and this time, we are comparing with h1 to h100 and h200 to h300. If you comparing two time interval h1 to 100 and h200 to 300, in this process, this statistical property expectation of h should be constant. Variance of x should be a constant. Covariance also constant. So wherever time interval you take in, this is a one stochastic process. We can say it is a white noise process. So h1 to h100, 200 to 300. We take on the process from here to here and here to here. We have to compare with the expectation of h and variance of h, covariance of h. This should be a same. Not only like that, if you take from 100 to 200, if you take from 100 to 200 and 300 to 400, this statistical property should be same. If you take from 50 to 150 and 250 to 350, wherever you take in the process, wherever you take in the small time interval, we analyzing the expectation of h, variance of h and covariance of h. The statistical property should be same. From here to here and here to here also should be a same. That we can call, if it is a same, we can call it is a strictly stationary. If it is not a same, we can say it is a non-stationary. This process is non-stationary. So stationarity, one strictly stationary example is white noise process only. And now we can see the graph itself, we will understand whether it is a strictly stationary or not. Whether this one is depend on the time. We will draw some other graphs. You will understand whether it is depend on time or whether it is stationary or not. I will draw different types of graphs. So time is going up. My stochastic process is like that. My process is like that. Then what will happen? You see this picture. There is a increasing trend. You see, there is a increasing. Time is increasing. Time is increasing. Trend is there. There is a one trend that is increasing the trend. So we can say there is a one trend. So if you compare with these all these statistical property from this point or this point, it will be different because this one is depend on the time. Some variance will be different and expectation of h will be different because it is a increasing trend. This process is increasing. Wherever you take the point, it will be a different. So whenever you see the graph, there is a trend, then this process will not be a strictly stationary. Now you see another graph. You see there is a decreasing trend. So there is a trend is there, decreasing trend, we can't say it is a stationary. You see this graph will be whether it is stationary or not. This also depend on the time it is coming down. Process is increasingly higher than it is coming down. This process also we can't say the stationary. And one more trend, other than trend, there is a see the process, there is a seasonality, same. So if you compare with this point and this point, and you compare with this point to this point, this will be a different statistical properties from comparing this point to this point and this point to this point also, it will be a different. So if there is any seasonality, we can say this both will be non-stationary. If any trend is there in the graph, any trend, any seasonality, that we can't become it's a strictly stationary. It will not be a strictly stationary. You can say it is a non-stationarity. We'll do some example. We'll understand what is a stationarity and how to find out. Once you draw the graph, you understood what is a stationarity. Now we will see the equation. How we'll understand the ST. This is one statistical property, stochastic process. 3 plus 3t. This is a 3t plus ST minus 1 plus 1 YT. YT is saying YT is depend on identical IID variable. It is a normal distribution, standard distribution 0 to 1. This example is available in our books. So ST is equal to 2 plus 3t plus ST minus 1 plus YT. YT is value of the YT is a IID random variable. It is normal distribution to standard normal distribution 0 to 1. You see whether this process is stationary or not. If you see the picture, you will understand there is a time dependency. 3t. So if time is equal to 1, the value will be 3. Time is equal to 2, this value will be 6. So in this equation is having the 3t, this is depend on the time. So we can't say this one is independent of time or there is any strictly stationary. If time dependency is coming, it will not be a stationary. So we can say directly it is not a stationary. So one more equation. EST is equal to sin omega t plus yt. You see here also there is a time dependent. So whenever you see the equation, if there is any time dependent, it will not be a stationary. We will take one more equation. Before that, we will explain what is the weakly stationary. So we see the strictly stationary. If it is, we have to check the whether it is strictly stationary or weakly stationary. Weakly stationary means this is correct. Expectation S should be constant. Variance also constant. Covariance is depend only on the lag. Depend on lag. Covariance is depend on the lag. What is the lag? Now one process is ST and one more process ST plus 1, one more process ST plus 2. If you take it like that, what is a lag? We can say lag 0 means it is ST. This one is lag 1. Next process you can say it's a lag 1, this is lag 2. So this value will be a lag. So covariance is depend only on the lag. So compare with the strictly and weakly stationary. Once it is a weakly stationary means covariance depend only on the lag. Remain means and variance will be constant. So we'll take one example for weakly stationary. St is equal to yt minus 1 plus yt. St is equal to yt minus 1 plus yt. Yt is depend on the independent random variable, IID random variable, standard normal distribution 0, 1. So once you see the equation, we can't say it is stationary or not. There is no time dependent. So yt minus 1 plus yt. So we have to check whether expectation of s is constant, variance s is constant, or covariance is constant or not. So we'll start with analyze each terms. Expectation of st. How to check expectation of st? You see expectation of yt minus 1 plus expectation of yt. So expectation is 0. Here is it is 0. So this value is 0, 0. So we can say it is a 0. Here it is a standard normal distribution. So 0 to 1. So expectation is 0. So this value will be 0. Next is variance of x. Variance of st. It is a independent. We can write variance of yt minus 1 plus variance of yt. So variance of yt minus 1, variance of yt. Variance is 1. So variance of yt minus 1 is 1. Here variance is 1. So this is also constant. So variance also constant. So this 2 is correct. This one is correct, and variance also constant. Next we have to check the covariance. Covariance will take more about the covariance will take in the auto covariance class. So covariance st and st. So lag 0. This means st is comparing with st. That means lag 0. There is no lag. So covariance of st, st we can say it is a variance of st. That value we know already. Covariance of st, st should be a variance of st. That value we know that it is a 2. Next is lag 1. Covariance of st is comparing with the covariance of st plus 1. Next lag. St is comparing with the st plus 1. How we can write the covariance of lag? Say covariance of, we'll write here. You see, first we see what is a st. St is a yt minus 1 plus yt. What will be st plus 1? How to write st plus 1 is equal to yt minus 1 plus 1. Here we have to give plus 1 all the term. Here is yt plus 1. So minus 1 to 1. This term will be yt. So st plus 1 is equal to yt plus 1. So this equation will be covariance of, equation we can write yt minus 1 plus yt, comma st plus 1 we got it, yt plus 1. This is our equation. Covariance of yt minus 1 plus yt plus 1. Just give one plus 1. Here is a plus. Give 1 plus 1. We'll get the answer. So now covariance has to compare. How to compare the covariance? Covariance has to compare yt minus 1 with yt, and yt minus 1 with here and here, yt with yt, and each term has to write. So covariance of yt minus 1 with which one? Yt. First term. first term yt minus 1 with yt. So this is 0, yt is 0, yt minus 1 and yt is independent, there is no relationship, so it is a 0. And covariance of yt minus 1, next one, this is first one, this is second one, third, fourth. So next one yt minus 1 with yt plus 1, this also 0, there is no relationship, it is independent, this we can say it is 0. Now other terms, covariance of yt comma yt. So yt is dependent on, we already know, so yt is dependent on 0 comma 1. Yt comma yt means it is a variance of yt. Variance of yt is equal to 1. Variance of yt is equal to 1. So this term we got 1. Next one yt into yt plus 1. So covariance of yt compared with the yt plus 1. It is independent, it is equal to 0. So total entire process covariance of yt minus 1 plus yt, yt plus yt plus 1, this all terms has to plus it. So 0, here it is 0, then plus 0, plus here it is 1 plus 0, it's 1. You got the value 1. So lag 1 is 1. Next has to check the lag 2. Now we are going to check the lag 2. So how to write the lag 2? st plus 2. Here we go, here is st, here st plus 2. So everywhere you have to give st plus 2 plus st yt minus 1 plus 2 given plus 2 yt plus 2. Here minus 1 plus 2, how what? It will be a plus 1. It will be a plus 1. So yt plus 2. So covariance of st is comparing with the st plus 2. Second lag. And now comparing with the covariance of st is comparing with st plus 2. So st plus 2 we know. So covariance of st is yt minus 1 plus yt, and st plus 2 is yt plus 1 plus yt plus 2. Now we are writing the covariance. How to write? This one is, we have to check first with the yt minus 1 with the yt plus 1 and yt with the yt plus 2, then yt with the yt plus 1 and yt with the yt plus 2. Covariance of yt minus 1 yt plus 1, there is no dependency, is equal to 0. So if you compare the yt minus 1 and this one, we can write covariance of yt minus 1 and yt plus 1 plus covariance of yt minus 1 with the yt plus 2 plus covariance of yt comma yt plus 1 plus covariance of yt comma yt plus 2. So we have written the four terms, yt minus 1 with the yt plus 1, covariance of yt minus 1 with the yt plus 2, covariance of yt t plus 1. This one you see, it is independent 0, here it is independent 0, it is independent 0, so total value will be 0. So we got lag 0 is equal to 2, lag 1 is equal to 1, lag 2 is equal to 0. Now lag 3 will be a 0, there is no dependency. So lag 3 will be 0, 4 will be a 0. Increasing the lag, it will be a 0. So in this process is depending only on the lag. So we can say it is a weakly stationary. It is weakly stationary. This process is weakly stationary. Weakly stationary, we have to check with the expectation of h is constant, variance also is constant, covariance depend only on the lag. We check this covariance function will explain autocovariance. This equation is like autocovariance equation, will explain that class. So we understood what is the concept of strictly stationary and weakly stationary. Thank you for watching my video. Please subscribe my channel. Thank you.